So a text input is commonly found in component libraries as these types of inputs are essential for gathering user data. And the component we will be building will encompass two different states. So the first state is what I'm calling kind of the standard view, which is initially presented to the user when they're entering data. And then the second state is what I'm dubbing as the error view, which is displayed if invalid input is entered at any time. And the starter code for the project can be found in the code sandbox link provided in the lesson manuscript. And feel free to fork the sandbox and follow along with the corresponding lessons if you want. So now we'll kind of go through the different files that we'll be using throughout this implementation process. And we'll start out by looking at app.jsx. So this file serves as the entry point for the project and will be the location where we render the text input component and pass in the props that the component accepts. The second file is textinput.jsx, and this is where we'll be spending a majority of our time. This file provides a boilerplate for the main text input component. The props with the star emoji next to them indicate the props that need to be wired up to make the code accessible, while all the other props have been wired up properly. Third file is textinput.css, and to get us started, there are styles already being applied to the input and label elements to make it more visually appealing than the stock styles that get included with those elements. And just a caveat that in a real-world application, you wouldn't typically target elements directly as we're doing in this style sheet. Instead, you employ more powerful and organized CSS solutions like CSS modules, style components, tail and CSS, whatever you choose to do. However, to keep things really simple and straightforward, we'll be using plain old CSS and making most of CSS selectors. And then as far as dependencies go, there really aren't that many. There's only two. First is the prop types package, just for some basic runtime type checking. And then additionally, we're using one of the SVGs from the radix icons package. So let's dive in. The first thing we need to do is ensure that the input has a label and that the two elements are properly associated. If we look at the current code in textinput.jsx, we'll notice that there is no label present. Let's fix that by adding a label element above the input element. Do that, and then we'll display in brackets the label prop that gets passed in. And now that you can see that the label is present, it says email address, because that's what we're passing in from app.jsx. And now that we have a visible label, we still need to establish a proper association between the label and the corresponding input. And to achieve this, we'll take the ID prop passed into the component and apply it to the appropriate attributes for the respective elements. So for the input element, we'll use the ID prop and assign it to the ID attribute. And for the label element, we'll utilize the ID prop and set it as a value on the for attribute. Since we're working with React, we'll use the HTML4 attribute to create the necessary association. Special keyword that gets mapped there. And now you can see that association is made. And then when you click on the input, on the label, it'll highlight the input indicating that the association has been linked properly. So now that we have our input and label elements properly associated with one another, we can move on to creating an accessible way to hide the label. And to do this, we'll make use of the hide label prop that is being passed to the component. So open up textinput.css and create a class called visually hidden that we will reference in the JSX file. If you remember from the labels and inputs lesson, there was a CSS snippet that keeps the information accessible to assistive technology, but visually hidden. We're going to copy and paste that same snippet and use it here. So now we can go back to textinput.jsx and wire up the hide label prop. In React, you can apply CSS classes using the class name attribute. We only want to apply the visually hidden class when the hide label prop is true, so we'll pass in a conditional that handles that logic. So when hide label is true, it'll apply the visually hidden class, and when it's not, it'll just return 0 classes. And if we were to pass the hide label prop to the text input component from app.jsx, you'll see that the label is visibly removed, but still made available to the screen reader. And if we inspect the DOM and look at the accessibility tree, we'll also see that the label is still present. Last but not least, we'll take a note from the color contrast and styles lesson and apply some styles to the input when it is in either a focused or disabled state. So if we open back up textinput.css, let's apply the focus class and disable class that we have in the lesson manuscript. And let's go ahead and wire up the disabled attribute on the input element as well. And let's actually test out the focus styles first by clicking or tabbing into the input, and we should now see a distinct focus state is being applied, making it more noticeable and user-friendly when the input is being interacted with. And if we open up app.jsx and add the disabled prop to the text input component, we can test out and see that the styles change to indicate that the input is not interactable when we have that prop being applied. And having these visual cues in different states ensures a clear understanding of the input status, enhancing the overall user experience with the input. Errors are inevitable in any application, and handling them gracefully is essential for a seamless user experience. In this lesson, we'll update our text input component to efficiently surface error messages, ensuring that users receive clear feedback when something goes wrong. To begin, we need to include JSX that will show the error message below the input. The text input component has an error prop that accepts the string value, which we will use to dynamically display the desired error message. Since we'll need to check for errors in a few places within this component, I've added a handy hasError variable that has been predefined and stores a Boolean that tells us if there are any errors or not. So open up TextInput.jsx and add the following code below the input element. The code block does the following things. It conditionally renders the error content based on the hasError variable defined earlier in the file that checks for the presence of any error string. It applies an ID of error message that will be used later on in this lesson to link a specific ARIA attribute to this content. Thirdly, it applies a class name error, which will be targeted in our CSS later to apply error styles. Last but not least, it uses ARIA hidden equals true on the icon, since it is used purely for decorative purposes, and we intentionally want to hide it from the accessibility tree to avoid unnecessary content being passed to assistive technology. So to get our error message to display, open up app.jsx and update what's being passed into the text input component. Let's go under the onChange attribute and add error equals invalid format entered or whatever string you want to display. And this will trigger the error message to get shown. And now that we have our error message being surfaced, let's ensure that people using assistive technology get notified when there's an issue to address. And we'll achieve this by applying the appropriate ARIA attributes, ARIA invalid and ARIA described by. Let's go back to textinput.jsx and tack on the following two lines to the input element. First, we'll add ARIA described by, and if hasError is true, we will apply the error message. And if not, we'll return back null. And for ARIA invalid, if hasError equals true, we'll return back the string true, else return back the string false. So we covered the ARIA invalid attribute earlier in the course, but as a quick reminder, ARIA invalid is used to indicate when the input value doesn't match what the application expects. So in our case, we conditionally set the attribute to true to show that the input failed validation. And when there are no errors, the attribute will be set to false. The ARIA described by attribute helps link descriptive content to the target element. It takes a space-separated list of element IDs that describe the current element. In our example, when errors are present, we use the ARIA described by attribute to point to the error message ID, which we added to the paragraph tag holding the error text. When there are no errors, we set the value to null, which removes the attribute from the input element so no additional description is associated with it. All right, let's do a quick recap. We've got the error message showing up when added and have used the right ARIA attributes to ensure assistive technologies know about the invalid input values. Now, the final part is to apply the styles to indicate the error state. Since red is commonly used with errors, let's try using that in our error styles. The hexadecimal value for the red CSS name color is this. Let's run that through WebAIM's contrast checker to make sure the red color meets the ratio requirements. And after running the check, we can see that the red doesn't pass either WCAG AA or AAA conformance for normal text. And since the error text is 16 pixels, falling into the normal text category, we need to pick a different color that meets contrast requirements while still conveying the error vibe. So let's consider a different color that has more of a maroon tint to it, and we'll replace the current foreground color with the following hexadecimal color. Now let's check that in the checker and see if the new color meets the contrast requirements for error text. Awesome, the new color successfully passed both guidelines, making it a good option for our error text and input border color. Now that we've selected our error color, open up textinput.css to update the styles when an error state occurs. And in this case, we'll apply that maroonish color to the input's text color and border input color. And we're utilizing CSS attribute selectors to target the input when ARIA invalid equals true. The beauty of implementing with an accessibility mindset is that it's not just for JavaScript and HTML. It seamlessly extends into CSS, making the entire workflow harmonious. And now you can see when the error styles are being applied, the input border color has that maroon tint along with the text color within the input. And when we inspect the accessibility tree, we'll see that ARIA invalid true is being applied, and the ARIA described by message is being linked appropriately. We aim not to rely solely on color to convey meaning. And in this example, we employed two different techniques when displaying the error message. Textually, we surface the error messages strategically by positioning it near the location where the error occurred and ensuring proper association for screen readers by applying the appropriate ARIA attributes. Stylistically, we enhance the error presentation with features like a maroon border around the input and maroon text for the error message. Additionally, we included an error icon to make the error more visually noticeable for sighted users. A great job on implementing our accessible text input component. Now our component can gracefully handle a wide range of scenarios.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.